Thank you, everybody, for joining today. We still have a few people that are entering the room, so we're going to get started in just a few moments. All right, everybody, I think we'll get started. Welcome to today's webinar, Stop Worrying on Serverless and Learn to Love Pipeline Feedback. My name is Jeannie Parker, and I will be your moderator. Today, we are excited to have Thorsten Hoeger, CEO at Taimos, and Michele Mancioppi, Product Manager at Instana, with us for today's presentation. Before I hand it over to our speakers, I have a few housekeeping items to cover. First, today's webinar will be recorded and available on demand after the live session, and will be sent to you via email, or you can access it through Instana's website. We'd like to hear from you during today's presentation. If you have a question for our speakers, please feel free to send it through the chat box on the right-hand side of your screen. We'll be answering questions both during and at the end of this session. If we do not get to your question during today's webinar, we will be sure to follow up afterwards. And with that, I will hand things over to our speakers.
Hello, everyone.
Hi, everyone.
Thorsten.
Hi, I'm Michele.
So long time no talking. Last time we had something like this. It was a chat about Fargate, and then we came up with the idea of doing like all the cool people on Twitch and make a live coding.
Exactly.
So what did we prepare?
Yeah, we prepared deploying serverless applications to AWS using the AWS Cloud Development Kit. So all the new things that are out there, and then get pipeline feedback when breaking the functions.
Because functions break all the time, and we're going to show it to
No,
you
but
today.
developers write broken code.
Yes. So let's hope that today we break it intentionally.
Yeah.
For a difference. How about we just jump into it, shall we?
Yeah, sure.
While Thorsten sets up, let me set expectations. So we are going to, as Thorsten said, we're going to deploy functions on AWS. We are going to see functions that break in Instana. Instana monitors end-to-end Lambda functions in Python and Node.js. Today we're taking Node.js out for a spin. We are going to see data live in Instana. We do live coding exercises, so it's going to be interesting. And as we see the things break, we're actually going to go step by step, improving the way we visualize things in Instana, pushing more information. Instana has a capability called pipeline feedback that allows you to tell Instana when you're deploying something. And then Instana will show it to you and how that relates with, well, things changing and of sometimes breaking because of the change.
Perfect. So our starting point is, as Michele said, we want to deploy a serverless application using a Lambda function. For the sake of simplicity and because it's the latest and greatest thing, we're using the Cloud Development Kit, which is a library or platform to deploy applications and deploy or write your infrastructure as code in TypeScript or Python or Java, not using YAML or JSON. So everything we're writing here is infrastructure, but we're using typed classes in TypeScript for this. So to start, we will create, we're running CDK init. This is what I've done already here. And CDK init will then populate a new project, TypeScript project, and we'll start with this. What I did beforehand, because NPM always takes some time, is install the dependencies for Lambda and the dependencies we will need for pipelines like CodeBuild and CodePipeline later on. In this demo, we are using the version 1.56. The current version is the 68. But it's the same code. It's about a weekly release, so it's fine. So our first stack we will implement, which is basically a CloudFormation stack for people familiar with CloudFormation, will host our Lambda function.
And for those that are not familiar with CloudFormation, how would you describe it?
Not familiar with CloudFormation? Good question. So we have resources in AWS, and we will provision these resources using infrastructure as code, which means we will define our desired state in a template, and this template will then be handed over to AWS, and AWS will then provision the infrastructure. And one of these collections of resources is called a stack. And one stack is one piece of application infrastructure that is modified in the process of one update. So one update always targets one stack and does all the things in one stack, either completely or not. So it's an atomic execution, updating a stack. Everything works, or it's the same as before.
What would be the granularity of a stack? Are we talking single EC2 hosts all the way to an entire VPC with inside several services like Lambda or Fargate?
So both is possible. I've seen both with customers. And as always in IT, the correct answer is in the middle. So the thing is, having scopes of things you modify together. So what I normally do is having one base stack with the main infrastructure like the VPC and VPC endpoints and things like that. Having one stack with the databases and the S3 buckets and things like that, because you don't modify databases that often. Then you have one application stack and maybe another stack on top that's doing just routing and DNS, load balancing, things like that. With the serverless application, it's databases and Lambdas.
So you could say that a stack could be one microservice in terms of granularity.
Exactly. For serverless applications, that's the other way you write it. You have one stack hosting your API, and then per microservice, not per Lambda, but per microservice, you will have one stack just to make it easier. Otherwise, it's just hundreds of resources in one stack, and it's no idea what's going on. So that's how you would normally scope it.
And one aspect of that is very important in DevOps is the fact that after you declare what your production should look like, then the cloud provider or some automation behind the scenes is making sure that reality is as close as possible as the specification. So how does a stack do what is called as reconciliation?
So for reconciliation, so you mean like seeing if the reality still is the same?
Yeah.
So first of all, I try to prevent the reality from diverging from the stack, normally by not allowing people any write access to the AWS account. So the only way to write is using CloudFormation. There's no way to write in this account. If it still happens, there's something called drift detection that helps you finding these changes and then deciding which way to go to fix them. So either fix them in the reality or adjust your template.
And so this is about intentional drift. When someone goes and wants to fix something quickly in production, and then they will, of course, forget what happened. What about if, let's say, Amazon terminates one of your EC2 hosts because it got a termination notice? Will CloudFormation spin up a new one for you?
If you use only EC2 instances, it will not happen because an EC2 instance is not a reliable construct. So I would say it shouldn't matter because you should not spin up EC2 instances outside of autoscaling groups.
So
and then it doesn't matter.
This is where I wanted to get. If you actually want to keep your production stable and have AWS do the work for you to keep aligned your specification and the reality, then you should organize your entities around managed computing resources by AWS, where it's part of the contract between you and AWS that when you say that you want 5 of these things, AWS makes sure there is 5, not 4 or 6 or 5 looking a different color.
Exactly. So that's why you want to go to Fargate, like we discussed in the last webinar, or you will go with serverless, or you don't care about instances at all.
That's even
and
better.
EC2 is the new legacy.
So let's have some serverless, shall we?
Yeah. So in this thing, we have our code describing one stack without any resources currently. So we want to start using CDK and create a function. So we're creating a function, which is coming from the Lambda package. I already imported it above, and it's called function. With all CDK resources, we have to provide a scope, which is a tree of resources. In this case, it's our stack, so this, and the name, it's called just function. And the third parameter is always the configuration of the resource. So our first configuration would be, we need a handler. A Lambda handler is the file name and method that is invoked when starting or executing the Lambda function. It's as easy as saying it's a file index.js and the method handler. And we need to specify a runtime. And as a runtime, we agreed to use Node.js. There are deprecated ones, so we don't want to use a deprecated version, so we're using 12.
Let's take a new one, come on.
Let's take a new one. Let's take 12. And it's still red, so there's one important piece missing. It's the code. So we need code for our Lambda function. And with plain CloudFormation or using the console, we now need to zip and upload our Lambda function code to an S3 bucket and then reference our S3 location. With CDK, we just say, okay, please use code lambda.code from asset. And from asset just says, please use this local directory and do the rest. In this case, I'm saying, okay, I want to use the current folder. And in the current folder, I'm going back one and using the folder Lambda. So this is this folder here, side to side with my lib folder. And it just says, okay, use this folder as your Lambda function code, and CDK will handle all the packaging and the uploading to S3. If you're using TypeScript, it will even transpile everything for you.
Are there also integrations for versioning systems? Like if I host it on GitHub, can it pull from there?
Directly from GitHub? That's not how it would be intended to be, because you should keep your infrastructure and your code in the same repository. Mm-hmm. So the assumption with, so it's possible definitely to do a workaround, but you should see your infrastructure as code application, which is in this case my CDK application, as part of your application. So it's part of the same repository, same release cycle, same pipelines, and so on. So it's not your application and your infrastructure, it's one. And especially with serverless, it's definitely one, because all the routing logic and everything managed is part of your infrastructure. So it doesn't make sense to have one JS file somewhere else. Okay, so now we have a Lambda function. And the next thing is we want to I should not talk and write, I should just copy. So what we're doing next is we're creating a CloudFormation output named Lambda function that contains a function name, because we need the function name to invoke the Lambda function. So we create an output, and we will see this output being there. So this is our Lambda function. If we now log into AWS, we could do a CDK synthesize. And this synthesizes a CloudFormation template that can then be deployed using CDK deploy.
Is it something similar to Terraform, Plan, or Helm chart template, the debug or dry run?
Not really. So synthesize is using the CDK TypeScript application and generating CloudFormation code, and deploy is then deploying this code using CloudFormation. So it's a two-step process. It's not planning and executing. It's really synthesizing, compiling your assembly, and then uploading it.
Oh, by the way, folks, don't let me have all the fun of asking things to Thorsten. Let's keep it very interactive, and please pepper us with questions. That's how we like it.
So now it said, oh, the app contains no stacks. Exactly. We created the stack, but we didn't add it to our application. So what we now need to do is to add one line here, instantiating our stack, adding it to our application, give it a name, and specify the environment where it should be deployed. So we always pin it to an AWS account and a region to make sure that we're not accidentally deploying it somewhere else. It's possible to do it without this, but you should always do it like this so it's not deployed somewhere else. But it's also possible to deploy into multiple accounts in multiple regions with one CDK application, which is perfect for dev, production, Q&A setups and something like that. So next try. And now it should synthesize.
The fact that it's taking longer is very promising.
So let's see what's happening. Yeah, it's taking not that long if you do nothing else on your machine, like streaming video.
Hey, it was better before actually we started the video. Thorsten was playing around with a super complex setup where the green screen was automatically replaced by an awesome background of Taimos, but his laptop was draining more battery than what the plug and the power brick were able to provide.
Yeah, that's why I changed it. So we have now a normal CloudFormation template. And as you can see, we want to stick to CDK and not write CloudFormation templates anymore. But it's a normal CloudFormation template containing the Lambda function and a reference to S3 where CDK will upload our code to. So if we deploy this, we have a Lambda function that we can execute. But
that's it.
As it's not a CDK presentation, but a webinar from Instana, that's not where we want to go. Michele, what do we want to do?
We want to trace it with Instana, of course. Come on.
Sure. So let's modify this code to enable tracing. So the first thing we need to do, or let's do it the other way around, I will add the new code and walk you through with line by line. So this is our new Lambda function. It's a little bit different, but we will have it in a second. So our code is still the same. Our runtime is still the same. But for the handler, we now have a fixed name, which is some entry point for Instana. So we will start Instana, and Instana will then start our code. For this to work, we need to provide an environment. This environment defines what is the original handler to call, what's the Instana endpoint, it's a serverless blue in my case, and what's the agent key. And as we, oh yeah, go on.
To put it in context, to trace something with Instana is as easy as telling the AWS Lambda where is the Instana backend and what are your credentials to talk to it, and then wrap with the handler your own code, and Instana takes it over from there. The code that Instana will use for wrapping and then automagically instrument your application is coming from a layer. And a layer is fundamentally, and you can think of it as an addition to the file system of your Lambda function that carries over all the things that are necessary to apply the Instana instrumentation. So there are 0 code changes. As you have seen, Thorsten did not have to change any single line in his Lambda function. This was all things that you do at deployment time.
Yeah, so we're just adding this layer. And as you said, it's basically an over-engineered version of a zip file. Yeah. And we're adding this. And as I don't want to show my agent key here on stream, and as you should not put secrets in your repository, I'm reading the agent key from a secret in AWS Secrets Manager called Instana. This has to be there. It was deployed in my account, created, and that's it. And so I can just use the secret in Secrets Manager, where you can store all your secrets to not put them in code or in your repository. So that's the whole change. Just directing or indirecting your call one time through this Instana layer. No code changes. And our code is still very easy. It's returning the event. It's the new killer feature for Lambda. It's a Lambda function that's returning your event.
That's something that you need every time you want to learn what is the new event available on Lambda anyways.
Yeah.
Always keep an echo Lambda around.
Yeah, that's why I start all my Lambda function with console log event. The only thing where you should not do this is if you write Lambda functions integrated with CodePipeline directly, because CodePipeline sends temporary credentials in the event, and you don't want credentials in your log files. For everything else, just print the event, know what's going on. Okay, and if we do this, we now just hit deploy. The deploy is always synthesizing beforehand. And we will see what's happening. So while this is deploying, maybe you want to walk us through the integration in Instana and see if I understand what I need to do.
Absolutely. So what you're seeing on screen, that's called it's a list of application perspectives. Thorsten, please click into the application perspective that we ominously called very breakable function. And maybe let's go a bit back in time to see some data, because the function so far hasn't done much, but we were trying things before.
Yeah, but let's see if it's still starting. Yeah. No.
I think the internet connection is not super fast. Can it be? I see, for example, a very grainy screen on my side.
Is it now working?
Yes. So this is the main screen, what we call the summary view of application perspectives. An application perspective is fundamentally an arbitrary slice of your infrastructure. In Instana, you have the complete freedom of deciding which parts of your calls between your applications, between your services, your functions, are going to be grouped into an application. And for this particular webinar, we went with an application perspective that is collecting all the tracing data coming from the function of Thorsten. In reality, you can specify application perspectives on pretty much on a whim, whatever you want. You want an application perspective that tells you how that data center is behaving. It's one click. You use a zone. Super easy. You want to provide use case centric application perspectives, saying, I want to know how that API is doing together with all the dependencies that power it. It's one setting. you want to do something focused around your Kubernetes namespaces to capture in one application perspective all the software that your team is responsible for. It's one click, and off you go.
Yeah, and the thing is, that's coming back to a question about scoping stacks. Your CloudFormation stacks are a tag in AWS on most resources, so you could filter your application perspective on the tags of your CloudFormation template.
Exactly.
Or your stack name. So this is another thing to scope your stacks around. So what do you want to filter later on? So this is our setup that we want to trace. So now let's see what our deployment did. Oh, our deployment deployed, no changes, because that's the state we already deployed earlier. And it tells me this is the name of my Lambda function. So what I'm doing now in the background is just starting a call, and I'm hoping it will not kill my machine. As you can see in my makefile, it's not doing anything crazy. It's just invoking this Lambda function once a second. And I hope this will work. No, it cannot work. It needs to be logged in. Otherwise, it's not allowed to call my Lambda function.
So what is this make run doing? Is invoking the SDK?
It's just in using the AWS CLI, using AWS Lambda invoke and the function name, and the payload is base64 encoded foobar. So in reality, it would have an API gateway. This API gateway will get calls from outside. These calls will then be routed to your Lambda function, be handled, and so on. In this case, it's just echoing the event and invoking it directly. So if we go back to our application perspective, we should now start to see data.
I don't think the calls are coming in.
Let's see if they start to come in. Maybe it's the AWS demo gods. They always change something.
No, now it's happening. It was.
Yeah.
You're in live mode? Yes. Now they start coming in. There was some time for the setup to occur, and the Lambda function was called, so it took some startup time. And now we are going to see like clockwork, a request every second, getting into the system.
So it's coming in. As we can see, our first invocation was a little bit slower because this is the cold start of the first invocation. And now it's just running smoothly. Yeah, it's not taking that much time to return the event.
And this shows you two things. First of all, Instana is processing all the tracing in real time, displaying data at the granularity of 1 second. This enables us to be super responsive in letting you know when something breaks. And secondly, the overhead of the Instana instrumentation is super small. As you see by the fundamental negligible return time of the function is like under 1 millisecond. The Instana instrumentation doesn't add measurable response time.
Okay,
all right.
So
let's break it.
Let's break it. So we will go to this thing. Do you want to break it all the time or sometimes?
Let's do it sometimes. That's the most interesting one.
Okay, so yeah, 50%. So I changed my code and I hit deploy. As you can see, you've just changed your Lambda code, hit deploy, CDK is repackaging it, doing CloudFormation updates. All these things are just happening without any further things you have to do. All this thing is magically done. So if we go to our AWS, we see there's this Instana CI stack, and it has all these events like updating things. So the last update was earlier this day, and now it will do the update. So it's packaged it published the zip file to S3, and now it's doing the update. And we should see the events here coming in. We see there's an update now in progress, and things are happening. So
something that we can also do is to follow in Instana when things start breaking.
So
that's going to be a good indication that the deployment has completed.
Deployment is done. Yeah, we see a change here. It immediately says, okay, there was a change. Because the code has changed, the version changed, Instana immediately told me there's a change in your infrastructure.
This is one of the secret superpowers of Instana, which is not only what your applications do, but also what changes. Because changes bring problems. And that's what we see, right? All of a sudden, there are errors that start occurring.
Yeah, there's definitely something going wrong.
How about we crank up the frequency of calling into Instana?
Yeah, let's try if my machine is able to handle this.
You could also use a watch -n 0.5 or 0.2.
Yeah, I could try. Maybe it is. So.
And now let's see how random is random in Node.js. Because from what I'm seeing on my screen, it doesn't look very random.
Okay, now there's things going on.
So we broke a Lambda, and we see in Instana tells you that something changed, and you can see what changed. There's a new version of the Lambda function. But there is an additional trick that Instana has up its sleeve, and it's called pipeline feedback. What Thorsten built with CDK is effectively a CI/CD pipeline. It's very easy to imagine activating that code with a GitHub action or Circle CI or whatever CI/CD of your choice. So something that we want to do is to feed into Instana the information that a new release has occurred. How would we go about it, Thorsten?
Yeah, so the thing is, I prepared something called a release marker script. And everything you need to do is just curling your Instana API, sending your API token that you should get from Secrets Manager and not put into your code. And yeah, post two releases with a name and a point in time. Point in time, I'm just using the current time. And the name is something I provide from the outside. So I could do release marker test. It's now going to AWS, looking for my secret value, and it published the release. And yeah, there is a new release. So let's look at this in a broader scope of things. As we can see, so now we see that where we started. This is where we get all the events coming in, and now we have this rocket. And this rocket says, oh, there was a release. So we immediately see in this case, this was a release and something changed. So if it's going up or going downhill beyond this point, okay, it has to do something with the release.
Oh, Instana has noticed that something is not going well.
Instana says, oh, there's something going on. So what's going on? Oh, our inbound call rate is erroneous. So there's something going on.
Instana is waiting just a little bit to avoid an alert storm when you have very short blips. For example, if you have a couple of calls going wrong in 1 hour, you don't want your on-call people. So Instana waited a little bit and then said, okay, this looks serious, start looking into that. And soon it will say, okay, this is very serious. We are upgrading it from a warning to an error. Yeah. And usually this is when your pager goes off.
Yeah. Currently it's just, okay, there's something going on, seeing what's going on later. Okay, so yeah, you mentioned pipelines. So there's something else prepared here called a pipeline stack. So it's a new file for a pipeline. So what we need to do is import some stuff.
Fundamentally, we're going to tell CDK to create for us the release marker as things get deployed.
And the whole deployment pipeline for us, including release markers and everything. So we are using CodePipeline for this. It's the AWS pipeline tooling. And we will put everything in here. So let's copy not only this part, but this part, and let's see what's happening here. So what we're doing is we're creating a new pipeline. We are adding a stage called source. And for this source stage, we're telling CodePipeline to check out GitHub. So our code is live on GitHub on this project, in this organization. Use this branch name to deploy. And our token is again in Secrets Manager because we don't want to have our access token for GitHub in our code. So this is checking out code from GitHub. And then we are adding a new stage or another stage called deploy. And for deployment itself, we will use CodeBuild. So we're creating a new CodeBuild project. And as our build specification, so what it should do is running npm CI to install our dependencies, run the release marker script, and then run deploy. npm run deploy is just an alias to CDK deploy in this case. As an environment, we specify the standard Linux image, so we don't need anything special installed here. And for the sake of simplicity, we specify an administrator role that is allowed to do anything in our account. Because no matter how hard we try to limit it down, in the end, this role is allowed to create a new role for our Lambda function. And if it's allowed to create roles, it could also create new admin roles. So we can just give it admin access.
Let's cut it to the chase, right?
Yeah, so that's definitely a security thing you have to keep in mind. If you go the CI/CD route, your CI/CD server gets administrative privileges to your infrastructure. But on the other side, nobody else does.
So the moment you secure the CI/CD, you're already better off than otherwise.
Yeah, otherwise you have admin privileges on all your developers' computers, which is not necessarily better than your CI/CD platform having it.
It depends how happy your developers are.
It's not about angry developers. It's about having some crazy modules or applications copying the credentials file from your machine. So, and then we're adding this CodeBuild project to our stage using the CodeBuild action. And if we then deploy this pipeline, which I did already before, we get a new code pipeline. And this pipeline then has our source and our deploy stage. And it's just executing npm CI, npm, sending the release marker and deploying our code.
Let's give it a shot. Let's fix the Lambda. Or maybe we break it in a more interesting way.
Yeah.
Let's fix the error and make it slow as hell.
That's what I think is a great idea. So let's fix this code.
How about we keep the random, but we make it wait. Yeah, exactly.
Like this?
Yeah, that's great.
Always prepared. Yeah, so we're doing it randomly. So 30% are waiting, the others are resolving immediately.
And this time we may want to have different watch commands because the watch is going to block. So if we're not going to send in parallel multiple requests.
Currently, we're sending 2 in parallel.
Okay.
Yeah. So one thing we need to do is add our pipeline stack to our stack setup. So now see what the changes are. If these are changes that are, oh yeah. That's why you have this pre-written. This is okay. This is okay. And we do our code change. We're writing a meaningful commit message, like fix.
It's the golden standard commit message.
And we push to GitHub with our SSH key being on an external security device and not being on our machine without a key. So in this case, it's a YubiKey.
key? Yeah,
exactly. It's a YubiKey and it stores my SSH key or my GPT key. So no stealing SSH keys because your SSH to your Git is now the entry point to your CI/CD pipeline. This is your master key to your infrastructure. So basically, your SSH key has administrative privileges.
Often you hear in demos like, don't do this at home, but actually we're telling you, do exactly this at home, just keep it safe.
Yeah.
Use two-factor authentication, use an external YubiKey or anything to that extent, and keep your code safe. Because all of a sudden, you are, instead of putting your hands in the console, you are actually describing what it is. If someone can change that description, with Instana, you're probably going to notice because of all the changes, but in general, it's not that simple.
Yeah. So as we can see, our pipeline started just now and is now deploying our code. And if we go into the details and look at CodeBuild, it ran npm CI, added all the packages, did our release marker call, and deployed our stack and finished deploying our stack. So when we go back to this, whoa, there was a new release, CI/CD test, exactly what we tried to do. And if we want to look at this in a broader scope to see the last one too, it's just going out of the window. There was the old one, and there's our new release. And
to 30 minutes.
With 30 minutes, we will still see everything we did. So, and if we go back to our smaller scope, we see, oh, our errors are gone. But
but there is something that is not fine. You see the latency chart. Thorsten, please click on the distribution button.
Sure. So currently it's okay. It's only 3 of them.
In the last 5 minutes?
In the last 5 minutes. So if I go to the last minute, this should look a little bit different.
Exactly.
Yeah. It's 2 of 6, which is 30%.
Yeah. And as the time goes on, those percentiles are going to shift more and more to the right in a very scary fashion. You actually, we actually could go and look into the calls that are slow. You can interact with this chart and tell it to show you the percentile. You can drag around. And then view and analyze.
Okay, I just lost your audio.
Oh, my bad. How about I share the screen for a second? I'm on the same screen as you are. So here we have our function. It's doing things, and we want to see what's going on with this high percentile. We select, we click a drill down, and Instana is bringing us to a view of all the calls that fit this particular area. We have on the x-axis how long the call takes, and we can drill down into each and every single call. Seeing exactly what happens. So in this case, the function is there is a match. For example, if we had the Lambda function calling other functions or databases that would add to latency, Instana would show you the entire tree of the calls from your entry point all the way to the deepest database, and just a lot of information about the Lambda function, where are the calls coming from, including the infrastructure entities, which we are not going to do this time. That's a different webinar. But ultimately, you have in Instana the possibility of seeing everything and drilling down in all the information. As a matter of fact, Instana is a portmanteau. It's a merging of two words for instant analytics. We are collecting all the data and slice and dice it for you in real time as you tell our tool where you want to drill into. It's quite unique. All right, so things got better. Our errors have gone away, but the latency has become atrocious. And of course, is the release to blame. Thorsten, do you want to take over the screen again?
Yeah, I will try. So I'm going back to my applications, to my very breakable broken function. And yeah.
Oh, how about we show another small thing? Put it in live mode on 5 minutes.
Yeah, sure. Okay.
And then let's set a time shift to the previous time window. This is a new trick that Instana recently acquired, and it shows you a comparison between the time window you're looking at, so the last 5 minutes, compared to the previous last 5 minutes. But it works also with, for example, the previous day or yesterday. So you have a very clear comparison, very easy to find out what has changed. And in this case, we see that the erroneous call rate has flattened, but instead the latency has spiked. It's very easy to analyze the behavior of your applications, of what you're seeing, also with respect to seasonality. It's quite powerful. So, Thorsten, what are we going to do next? Are we going to fix it?
We could.
Let's not do things in a bad state. Let's fix the function.
Okay, let's fix the function. Oh, yeah, I shouldn't add it inside the diff. So let's do it like this. Fix it again. And push it.
Oh, by the way, meanwhile, if you go back to Instana, we can show also the processing time. It's another, if you scroll a bit lower. So as you see in the bottom right, there is the processing time. Processing time is a breakdown of where is your latency coming from. In this case, all the latency is coming from within the Lambda function itself. So we categorize it as self. But if we, for example, were calling to a different function, let's say over HTTP, we would see how the time spent for our client, in that case, the watch command on Thorsten's machine, waiting for the response is broken down between what's happening within the Lambda function and beyond the Lambda function to the dependencies.
Yeah, so especially if you're calling DynamoDB or S3 or things like that, we would see, is it a slow query or is it just slow implementation?
Or both, who knows?
Or both. Yeah, we got a new change here. So I'm just disabling the time shift again. So yeah, now we should have a better latency here. Because or didn't it just, yeah. I just saw in the upper corner, the release is done. So if we compare it to the whole time, so we started with this lower level, then we did a change, everything was broken, and then we did the next change, and now it's getting better again. I hope it stays like this, and I didn't break it in this case unintentionally. But it should work. Yeah. So it's the same for our processing time. It keeps low, and it aligns with our code change. So the code change is even a little bit faster because this is when the change is done, and after the change is done, I'm sending the release marker. So Instana was faster than the release marker.
And then there is also the process of the new Lambda spinning up, the old Lambda spinning down, while it's training the requests that were allocated to it. So it takes a little time for the new function the new version of the function to take over and actually provide a better user experience than what we have had so far.
Yeah. So I think that's it from my side.
Thank you, Thorsten. This was great. So folks, you have been really quiet. Do you have questions for us?
I have one, guys, that was put into the chat. So the question was, is there an easier way to create pipelines like the one you built?
That's a very good question. Indeed, there is. So in this case, we had this pipeline stack and creating our CodeBuild and creating scripts here and so on and so forth. But with CDK, there is a new way to deploy CDK applications coming on that has several benefits. One of the benefits, if you look at your pipeline, we're running it in CodeBuild. So we're paying for every minute. And it's just deploying CloudFormation. We're just waiting for CloudFormation to finish, and we're paying per minute. So there's a new thing coming up that's using the CodePipeline native deployment function of CloudFormation, which doesn't cost anything else. And it's a lot easier. There's a blog post, create a CI/CD pipeline for your CDK app. And it shows all the things you do to deploy it. And it's a little bit, it looks similar, but it stays this way. Even if you do it multi-region, multi-account, it will stay at this amount of code. And it will then create one small pipeline, including self-updating the pipeline if you change it, going up to, okay, crazy multi-account stuff like for regions and accounts and whatever you like. You can find it on my blog on Taimos.de, or go to cdkday.com and rewatch my presentation on CDK Day about multi-account pipelines.
And since it is code, technically what we could do in a follow-up webinar is actually to ask Instana if, for example, the release should be rolled back, right?
Exactly. So we could either have a step that's asking Instana if everything's fine, or there's a CloudFormation feature called, I think it's called deployment monitoring, something like that. And you could say, okay, after deploying, wait for several minutes and look at some metrics. And if some of these metrics change, roll back everything. And we could, then combine these metrics that are watched with an Instana alert, for example. And the moment an Instana alert hits, this metric goes red and CloudFormation will roll back. Yeah.
And it's very easy in Instana to push your alerts pretty much wherever you want. We have integrations with several different tools, as well as a webhook that allows you fundamentally complete control of where you want, what do you want Stan to say to whom, right?
Yeah.
There is a question from Jefferson. I started watching at the end, but how does notification work? Can I watch my logs, for example, and notify depending on the message? Can I notify based on Lambda behavior? Yes to both questions. All the logs that you generate inside your Lambda function serving a request are automatically captured by Instana. We trace the logging libraries themselves and take those logs and add it to the trace data that is sent to the backend. And there is a functionality called Smart Alerts in Instana that actually allows you to define a possibility of alerting based on the content of logs that Instana collects. The same happens, of course, on the for example, Thorsten, if you click on Add Alert, exactly, the third entry on the left is about logs. And the beauty of Smart Alerts is that you can define your alerts based on the data that is already in Instana. Instana calculates baselines all the time. And also when you want to modify the behavior of Instana, for example, to react to some particular logs that for you are very important, when those logs are in Instana, you can also automatically see how many there were and whether your alert would trigger or not. It's super cool. And in terms of behavior of Lambda, well, of course we do how many calls are being served. You may want to be notified when there are too few calls to Lambda. What is the latency? What is the how many of those are erroring? How they are erroring? You have complete control.
All right, gentlemen, it looks like we are at the end of our time. Thank you both very much. To our audience, a link is going to be sent to the recording via email, or feel free to visit instana.com. You can also check out any upcoming webinars on our website at instana.com/webinars. Thank you all for joining us and hope you have a great day.
It was great having you again here, Thorsten. See you next time.
Thanks.